Hello and welcome back to our guided project. We're predicting mobile prices and we're going to use Ensemble methods today. So now that we've finished the pre-processing section, let's go into our modeling section. So modeling, so what I'd like to do first is I'm just going to print out all the columns that we're going to use. And then a really nice handy feature of this is you can just copy and paste this. And I like to put this into a list of features. Now this is really handy in case, let's say, I wanted to not include a feature. I can just comment that out. And this allows you the ability to experiment and play around with your data set. And so we have all of our features here. And what we're going to do, we're going to run that. And then I have price range. Make sure we're not putting this in mixed with our features, so that we can just copy and paste select this out. We have to be conscious that we want to make sure that price range is our target. So we're not going to use that as part of our features, because that would make life a little bit easier. If you know the answer already in the model, your model is going to be very good at predicting, but truthfully, we're trying to predict that value, so we won't have access to that at the time of our modeling. Okay, so we have features and targets. So what we'll do next, we want to assign the x and y. So we'll go x square bracket, or df square bracket equals features. So that's the list of the features we just put in. And for the y variable, our y target, we're going to go df, and we want to put inside of it target. So here, what we've done is now assign x and y. The next thing we're going to do is a train test split. So we'll go x underscore train, comma, x underscore test, comma, y underscore train, y underscore test is equal to, as you can guess, train test split. And what we're going to do is we're going to give this the x variable, the y variable, and we're going to go test size underscore test size equals to 0.3. And I'm setting, you'll notice I'm setting the random state. I just saved this from before to make sure that we're all using the same random state, and that I didn't forget to use number 42. If you're not aware of why the number 42 is significant, you see it a lot in Python, I would watch the Hitchhiker's Guide to the Galaxy. So anyway, so we have our x and our y. We're going to now do our train test split. And so perfect, everything runs well. Usually after we do our train test split, we want to standardize. We don't want to use our test features because we don't know those yet. This is our testing set. This is unseen data. So we want to standardize based on what's in our training set, and then we would apply that to new data, new unseen data. So what we'll do first is we'll go standard scalar, and we're going to assign that the object. So we'd go standard scalar, and we're not going to give any features, and we'll fit this right at the time. So we're just, again, fitting the x train. This is why we do this after the train test split, because we don't see the test data. We haven't seen, we're not supposed to know anything about the test data, so that we can do a thorough examination of the scores. And so we'll run this here. So standard scalar equals to standard scalar dot fit, and there we go. So what we're going to do is we're going to call the std scalar dot transform, and we're going to transform our x train. And then what we want to do, I'm just going to professional coding and just copy and paste this line, and we'll put it down below. And we can see here we're going to put it into test. So we'll do that now. Perfect. Okay, great. So now we've standardized our data set. Very important in terms of our modeling. What we're going to do is then head into our modeling, our actually building the model section. So the first thing, because especially with the ensemble methods, but with lots of the modeling in sklearn, we do the same workflow each time. So what we're going to do, we're going to build a little function to make our life easier in the rest of this. So what we'll go is model. So we're going to go define def model scorer. So this is going to give us the scores of our model. So all we're going to do is pass this the model object. And then don't forget your colons here. So we'll go model.fit x train, comma y train. Okay, so this is going to fit the model, that whatever model we give to it, and then what it's going to do is it's going to give us the score. So we'll go model.score, and then we'll give this the x train, comma y train. And we'll copy and paste this line again, and we'll just change the names to test. So now we need to get our test scores right here. So we'll go test, test. Okay, there we go. And so now we have our model score, a very simple function to kind of do the work over and over again. We're going to be repeating these steps, so let's just have our function do this. So let's run that, and everything's good. So now what I'm going to do, we're going to random forest classifier. So for a random forest classifier, we'll do max depth of 4, min samples of 5, and max samples of 8. This is a great opportunity to experiment and really play around with these different hyperparameters and see really which ones appeal to you the most, or which one give you the most score. So we'll assign that to RF, and then what we're going to do is we're going to pass our model scorer function, and we'll give it RF. So we're going to get a trained model back. We're going to get our score train, and we're going to get a score test. Okay, so let's run this one, and everything works good. We're going to then jump into the bagging classifier. So we have max samples 0.7, max features 0.7, and bootstrap features. We do want to bootstrap so that our data sets are independent. We're going to assign that to bag, and we'll give bag to our model score function, and then we'll receive the train version, the train, and then the test score. So let's run that one. And we'll do the same thing for AdaBoost classifier, which stands for adaptive boosting. And so what we want to do, we're going to give it 1,000 estimators, and we're going to give it a learning rate. Because we're giving it a little bit more estimators, we're going to give it a smaller learning rate so that it has time to slowly learn. We'll assign that to ABC, so AdaBoost classifier. We'll pass that to our model score, and we'll get back the trained model, trained score, and test score. So let's run this one. And then the next one is heading into the gradient boosting. And this is very similar to the idea of how neural networks work in a different way, but going down the gradient is how neural networks work. They use this gradient to find, and the idea behind this is you're essentially predicting the errors of the last tree. In this example, we probably have 50 as the default estimator. So it's always the new estimator, the new tree that we build is predicting the errors from the last one. And then the next one is predicting the errors from the last one. So by doing this, we actually help our model move down the gradient. It's a different way of finding the best fit line, but it does work really, really well. And so subsamples, min sample split, and max depth. And so we'll again do that, and we'll get our model back. And here we go. And so you should have access. I did the kind of tedious work for us. So I've done our workflow of putting this into a nice summary section. So we're putting our list of scores, our trained scores. We're going to assign that to the scores train. Our scores test is a list of our test scores. We're going to give it our model names. We're then going to put our scores. So score train is equal to score trains. So key value pairs in a dictionary. And then the score test is the pair to that. So the key is test, value is scores. And so just noting that we have the curly brackets and that these are separated by colons here. We'll then put this into a data frame. So pd.dataframe dict scores, so the dictionary we just made, and then we'll give this the index of our model name. So they appear on the nice left-hand side here. So if we run this, you can see here we get random forest bagging, and what we see here is that our model got a very good score, a bagging classifier got the best score. Very, very good on the training set. We're seeing some overfitting, and we'd want to play with the hyper features to kind of tune this. Ideally, what we'd want to do is move these two in line. We shouldn't be seeing such a big difference, but maybe what we could do is drop the train score down to maybe a 0.9, and by doing so, we'll become more general, which should make us more predictive, and maybe move our test score up to 0.9 as well. So this is a starting point to understand which model is the best, and then we'd want to go back and iterate through the different pre-processing techniques and different hyperparameters to try and tune our model. Thank you so much for joining me today. I hope this was fun for you. It was fun for me, and I will see you in the next guided project.